Okay, so Andrew really doesn't need any introduction from me, but to give an idea to people who might be new to the area, Andrew is a researcher, composer, engineer, instrument designer, and teacher, and he is exceptional in all of those roles. He's chair in design engineering and music at Imperial. He's holder of a prestigious ERC Consolidator Grant. He leads the Augmented Instruments Lab, which spans Imperial and QMU. He founded not one, but two spin-out companies, Bella and Hotkeys, both of which are to the betterment of humanity. He's a pioneer in the use of Kickstarter by music interaction researchers, and indeed any researchers. He's got undergraduate degrees, both in engineering and music from MIT, where he graduated in the top 2%. He's got a PhD in composition from Pennsylvania. He's a prolific composer. Check out his album on Innova Music. If you're currently doing a PhD, I recommend trawling through the PhDs of students he's supervised. That's a treasure trove. If you're interested in learning audio programming, then look for his course using Bella and C++ on YouTube and GitHub. But finally, coming to methodology, where Andrew has played a pivotal and midwife role at various points, let me hand over to Andrew on how this might all apply to digital musical instrument design.
All right. Thank you very much, Simon, for the extended introduction. And I'm so delighted to be here for this seminar. And thanks, Christopher. That was a really clear talk, which I think mirrors the clarity of that paper, which was for me incredibly influential in taking really difficult concepts and really distilling them down to things that you could really kind of wrap your head around. And then from there, that's a kind of entry point to encountering some of those sources for the first time. I'll share my screen here and hopefully not screw this up when the lights will turn on in this room. I think you asked a very good question at the end, Christopher, basically about how the instruments that we design help us be the musicians that we want to be, and hopefully that'll be something I'll dig into here a little bit. Hopefully everyone can see my slides here. Is that working? Can I get a? Yep. Thank you. Great. Yeah, I guess so. Simon's already said a bit about where I'm coming from. I guess I just also add that I am a string player myself. I play the viola, and string playing will be a kind of subtext of some of the work that I'm doing right now. So I appreciated the cello imagery from Christopher's talk. Also, because this is going to be a fairly theoretically driven talk, there's going to be a number of fairly extended quotes from different people who I've found inspiring over the years, including I see a number of the people who are on this call today. So thank you for being here. So this is the Augmented Instruments Lab, and really so many of the ideas that I have in this space come from conversations and joint work with the people in the lab and the alums of the lab. So if you want to know more about what we do, head on over to instrumentslab.org. The publications list at least is kept up to date, and you can find some information about the various instruments and projects that we build. I'm going to put a particular plug in for a paper that Landon Morrison and I have coming up in CHI in next month. The preprint's already online. You can find it here. And this is very much picking up on the Entanglement HCI paper and kind of riffing on this from a variety of different perspectives in terms of what it might mean for musical instrument design. And I don't need then to introduce Entanglement HCI because Christopher's already done this extremely well, but basically just to say that entanglement we are using as a kind of umbrella term to encompass a number of sort of sympathetic but ultimately quite distinct theories. One of them in this talk that'll be particularly important is the Agential realism of Karen Barad. There's a few implications that I think are worth pulling out. A lot of these entanglement theories will reject convenient dualisms, things like nature over here and culture over there, or mind versus body, or human intentionality versus matter as a kind of inert substrate onto which actions can be inscribed. we also find that entanglement theory in its relationality has a way of decentering the human. Human subjects are no longer the center of every single story. Agency is something that can be shared with the material world in a flexible and kind of enacted sort of way. So in this paper that Landon and I wrote, we structure this as a dialogue. Like as in literally the paper is written in two different voices, where Landon and I will each have write things in the first person singular. And so we're coming from slightly different places here. For me, as a musician, a composer and violist, an electronic engineer, HCI researcher, I'm particularly interested in the implications for design. Landon is coming from the world of music theory and media studies, although also a violinist, and is interested maybe in the inverse of that, what practice can tell us about theory. And so our paper then, we describe it not just as a dialogue, but as a diffractive dialogue. This then picking up on the metaphor of diffraction, which comes from Barad and Haraway. And the title itself, Entangling Entanglement, is a riff on Barad's paper, Diffracting Diffraction, which sort of enacts this kind of process of reading divergent perspectives through one another, kind of looking for patterns of difference. Interference patterns is the kind of optical metaphor, without attempting a synthesis or reconciliation of different perspectives. Now, I literally cannot present this Chi paper myself. It is a dialogue with Landon. So this is going to be a partial perspective. And I believe on Friday, Landon's going to have his own partial perspective at Sonorities in Belfast. So each of us will present our particular spin on the ideas that we've been working through. Right. All right. So a little bit of a stock check here. Okay. So what, right? What is it that we really want to get out of these entanglement theories as HCI researchers, as digital musical instrument designers, as creative practitioners? And for me, one of the questions that I've been grappling with is this question of these big weighty theories, these entanglement perspectives. When I then sit down at the lab bench because I'm going to build my next instrument, I'm going to write some code, I'm going to build some circuits. What's supposed to happen differently because of all of this kind of heavy theory? And how do we then operationalize that into future design practices? That's the kind of motivating question for me. And so I guess maybe starting from what we're even talking about with entanglement, there is this sort of sense that everything is connected to everything else. So you might have the idea that, you have design tools, they suggest certain things. You have the objects that those tools are designing. Maybe those are musical instruments. Well, the tools and the objects contain ideologies inscribed into their technical systems. We have the mind bodies of the musicians who were involved in these things, the kind of personal identities of the human subjects. Musical cultures are kind of implicated in this. You have epistemologies, you have economics, you have politics, and so on and so forth. And I think a risk of all of this is that this kind of sense that everything is attached to everything else kind of just dissolves into a sort of uniform grayness that actually acts as much as a kind of paralyzing agent as it does as a sense of inspiration. Because, if everything is connected to everything else, and ultimately we can't even make the first kind of statement about the identities of things, where are we even supposed to start as designers? And basically, how should we untangle this? Because entanglement has to have a more specific meaning than this sort of just generic sense of everything being interconnected. That question is part of what I'm grappling with on this ERC project entitled Rudiments, which is around entanglement theory and digital musical instrument design. And this also connects to some of another point that Christopher made, which is around questions of responsibility, because some of the technologies at play in the Rudiments project are things like embedded computing, computer systems embedded into musical instruments and other objects, and of course, AI technologies. The proposition not being that it's so novel that these things could be used for music. Of course, they will be used for music. They are being used for music, but there are moral and ethical questions here. Who is using them? For what ends and what value values are reflected in the process. So there's a need for a bit of a critical stock check of what we're doing and why, and how the technical decisions that we make are ultimately carrying cultural, aesthetic, even political implications. Another source that I'm going to draw on in this talk is Philip Agri, who has this wonderful little article that I found really inspiring. So Agri was basically studied AI at MIT in the 1980s, became very disillusioned with the whole enterprise and wrote some really cogent critiques of it, and talks about this sort of vertigo of speaking strange disciplinary languages in a wobbly fashion without quite knowing what the words meant. This is more or less where I am right now. So if you're one of the people on this call who does know what the words mean a bit more, bear with me, and hopefully there's there are some points that will come through from here. One of the other things that I find coming up a lot in conversations I have, or in sort of critiques of different work, is sort of begins, well, that depends what you mean by whatever word. That depends what you mean by expression, by creativity, by virtuosity. And there's this whole literature in the digital musical instrument space, particularly around the New Interfaces for Musical Expression conference, which is trying to unpick what a lot of different words mean. Here I'm gonna pick a particular bone with expression, and I'm gonna quote at length from Michael Gurevich, who has, I think, a really useful way of kind of deflating this notion of expression as as this sort of thing. We build instruments in order for those instruments to be expressive and to serve as vehicles for our expressive content. And so Gurevich in this article talks about scholars enumerating features of musical styles, and then basically trying to figure out how we generate technical systems to somehow enable those, and that the discourse in NIME has a way of conflating this ambiguously defined expressive content with the means by which it is expressed. We can go a bit further. We could talk about, well, what do we mean by things like instruments? What do we mean by interfaces or controllers? And there is a whole debate that's gone on for many years in the NIME literature about when is something an instrument versus an interface versus a controller. I'm not necessarily tremendously interested in the boundaries between these words, but I think it is useful to create some trouble around these identities. And here, Tim Ingold is a really useful source. Ingold, as well as being an anthropologist and basically a philosopher, is also a cello player and writes about playing the cello and how when he begins to play, that what had been a recognizable, coherent entity becomes something more like a bundle of affects, a meeting of bow hair, rosin, metallic strings, wood, and fingers coupled with resonant air. He says, bundle them together and sound erupts as through a fissure. I really like this as an example of the kind of fluidity of boundaries between things. We can go a bit further. We can talk about, well, what do we mean by performers? What do we mean by composers or improvisers? Simon Waters is also picking up on entanglement discourse from a different angle and talking about musical instruments not being objects, but processes, and talking about this performance ecosystem that sort of refuses obvious distinctions between performers, instruments, and environments. And we can go further, right? Pitch, volume, timbre. What do we mean by music itself? Here's the point. I think we're spending too much time sometimes thinking about what words mean on the premise that somehow decoding the meaning of words is actually a useful exercise to begin with. So here I'm going to go back to Barad, who talks about how language has been granted too much power. If we spend a lot of time thinking about what we mean by expression, or for that matter, what pitch, volume, and timbre are, the kind of suggestion is that these words have stable and universal meanings, which can somehow be independent of a context and an observer. If we follow that line of argument, we might think that the scientist is out to discover what expression is, what is the fundamental essence or nature of creativity. I'm not sure that's the most productive way of thinking about things. I would say that the entanglement view instead would suggest not that words have no meaning, not that these concepts are useless, but that we should always think about them in situated, specific, and kind of relational environments. All of these terms acquire their identity in relation to the context that they're in. So let's not go chasing universals. For example, music. music is a universal language, it's sometimes said. I think that is clearly false. There is no one generic sort of human universal notion of music. And if we take any musical instrument whatsoever, this Steinway piano, for example, we can query it. We can query whose music is encoded in that instrument. What kind of performer is that? What kind of musician is that making us? For any instrument, digital or analog, it's probably worth thinking about things like in what context the designer expects the instrument to be played, or what aesthetic ideas the instrument suggests to the performer. Thor Magnusson has a very nice paper about this, talking about basically the things that instruments tell us. The piano keyboard tells us that microtonality is of little importance. The drum sequencer tells us that 4/4 rhythms and semiquavers are more natural than others. The digital audio workstation says it's perfectly normal to repeat the same short performance over and over in the same track. Tools carry ideology. Tools influence the way we think, and none of these things are neutral. I want to take a little trip back in time to one of those bits of technical standards that's just kind of in the water now in musical technology. And of course, I think most people on the call will be familiar with this. That, of course, is MIDI. Somebody please speak up if the sound doesn't play properly.
About 3 years ago, musical instrument manufacturers got together to decide on an interface system that would allow anybody's electronic musical instrument to connect to anyone else's, and they came up with MIDI.
All right, so fine. This is 1985. This is about 2 or 3 years after MIDI was introduced, and let's see what it's about.
I'll just turn down the synthesizer so we can now only hear the piano. So what information can we send? I think the most important is key event information, which will tell the piano which notes I'm playing and when I'm playing them. And it will also send dynamic information, which is how hard I hit each note.
Right, okay, so now we're starting to get some specifics. Key event information, which notes I'm playing and how hard. All right, we'll carry on.
So by using MIDI, up to 16 different instruments can be independently controlled because you assign each one a MIDI channel number. And this is really useful when they're to be played by a sequencer or a computer.
Now, aside from loving the 80s-ness of this, this is actually a really problematic turn, right? Because we're going from key event information, which notes we're playing and how hard, to up to 16 different instruments can be controlled. And so basically, who is to say that this is a reasonable protocol by which to control different kinds of instruments? And indeed, this notion of control has its own problems. So it's maybe worth kind of stepping back from the idea of a MIDI as a generic substrate for music to be expressed, to think about where this is coming from and why, and what interests are bound up in it. This is the early 80s. You had essentially a self-appointed consortium of keyboard and synth manufacturers from North America and Japan that got together to sell more instruments by having a common standard, but also respecting the technological limitations of the time. So it makes loads of assumptions. It makes assumptions like music is made of notes. That is actually a highly disputable assumption with virtually any style of music, except perhaps Western acoustic piano music. It makes assumption that these notes have discrete onsets and releases, that they're organized 12 to the octave, most usually in equal temperament. And this protocol has traveled the world over 40 years and absolutely transformed many, many, many different styles of music, distant from the places that it started. And I think this is a position of ethical responsibility, but I'm not sure that it was ever really conceptualized as such when it was first introduced. Just to take these ideas and kind of represent them diagrammatically, the sort of premise is that we have this vague notion of music. Music is somehow constituted of a set of objects that we would call notes, that each maybe have some sort of timing about when they arrive, and that each note can be further decomposed into a pitch and a velocity, each of these essentially being discrete elements. Of course, there's a lot of problems with this. This ideology is very normative to Western keyboard music specifically. It's incredibly reductive. It squeezes out lots of important features from lots of different kinds of music. But then also, and this I think gets to the entanglement issue, it assumes that these ideas like notes and timings and pitches and velocities have a certain kind of stability that I think really is not there absent a very particular context, considering all of the specificities of it. And for this, so here I'm going to do my string player thing, and I'm going to tell you about one of my absolute favorite pieces of music in the entire world. And this is one of the late Beethoven quartets, Opus 131 in C# minor. And it is written as notation, of course. And so in principle, you could encode this as a set of MIDI notes. And yet within this score, the individual notes, this fourth note, for example, of this fugue subject, there is a universe inside this one note. The details of exactly how this is articulated over time, the way that that relates to what's around it, the way that the different voices play off against one another. Good luck telling me how that fits into a pitch and velocity sort of space. And I'll give you as many continuous controllers as you want. And I would posit that there's still just something missing about our representations of music. I'm going to play you just a little recording of it, and just something to keep in your ear as we go forward. Right. So maybe someday I intend to give a talk like exclusively about this piece and why about 15 years of instrument design ideas I have are somehow traceable to this, but I'll save that for a different time. But I think the point is there's a good luck kind of coming up with a set of words that describe this and then saying that those words essentially are a kind of complete and sufficient description of important aspects of what's going on here. I mean, we could make the same argument about emotion spaces. What is the emotional content of this? Can I put this on a valence arousal space? I mean, it's almost kind of silly to think about the richness of what is in a piece of music like this versus the reductivity of the kinds of numerical representations we're often looking for. Anyway, I'm going to go back to Agri for a minute and give you a little bit of a longer quote, because basically what Agri is saying is that what computational systems are trying to do is essentially to build representations like the ones that I've just described. He says computers are representational artifacts, and the people who design them often start by constructing representations of the activities that are found in the sites they will be used. A computer then does not simply have an instrumental use in a given site of practice. The computer is frequently about that site in its very design. Think about this through the lens of the MIDI protocol. That's kind of what's happening. The people who designed this protocol constructed a representation of musical activities, and then essentially the systems that they built, the material objects with their digital behavior, essentially are very much about that kind of that representation. And Agri goes on to make the provocative claim that computing has been constituted as a kind of imperialism. It aims to reinvent virtually every other site of practice in its own image. And I think there too, you could see the way that MIDI or the digital audio workstation have this kind of tendency to reinvent the musical practice that it purports to represent and to enable somebody to make. It is not a neutral substrate for expressing musical ideas. It's essentially redefining music to fit its own kind of terms. Now, Agri's main preoccupation is around the AI discourse of the 80s and 90s, although I think a lot of it is really prescient to where we are right now, both in AI again, and also in other areas. And he has a lot to say about the way that that kind of language was conflating representations with the things that they represent, and that there's a kind of slippage between the technical and the vernacular meanings of terms that are kind of simultaneously precise and vague at the same time, and that a lot of the kind of, I don't know, the sort of political power of the AI discourse relies on that vagueness. and that the whole thing is rather closed and self-referential, such that he says that basically the seemingly commonsensical demand to prove alternatives and practices actually a demand to express disagreements with the existing language within the existing language itself, and this is nearly impossible. Okay, so what am I talking about here with respect to digital music? Well, let's think again about these representations that we have built, the MIDI protocol, for example. Now, let's start with that as a basis and add some material tools like this one, the Makey, a wonderful little piece of maker technology, which essentially lets you turn any arbitrary conductive object into a touch sensor of sorts. And what happens when this kind of technology encounters those ways of thinking? Well, you end up with really reliably repeatable ideas like banana pianos, for example. You turn your fruits into a keyboard. This one is this note, this one's this note, this one's this note. And I'm not going to read the whole quote from Emily Dolan, but this is a wonderful little article talking about how basically building things into a keyboard and conceptualizing them that way turns random sound objects into something controllable. So what's going on here is that there's this sort of link between the material, which is the keyboard-like interface, pitches laid out spatially, and a certain kind of discourse, for example, a discourse of control and virtuosity. And this gets toward what Karen Broad talks about as, quote, a material discursive practice. Another way of looking into this sort of space, which Landon and I talk about in our paper, is this idea of claviocentrism, which is a term I'm borrowing from Ryan Diduck, who talks about the centuries in the making cultural logic that places the piano keyboard in the middle of the musical instrument ecosystem. But this doesn't all have to be about pianos. We also see that when people encounter digital tools for making musical systems, there's certain kinds of things that come up over and over again. One of them being the theremin-like instrument. I don't here mean radio frequency emitters and waving your hands in the air. What I mean is essentially the assignment of musical concepts and representations to orthogonal axes, and then sort of using that as a sort of control space. Pitch and amplitude around the XY axes, for example. And that in turn is a kind of a microcosm of maybe a bigger issue that I've been kind of grappling with in the NIME discourse for a while, and the best way I have of describing this is essentially to call it design by analysis. The idea being that I want to make an instrument to make music. What I'm actually thinking about is maybe a particular style of music. I may or may not be aware of that. But then what I do is I kind of go and I rack my brain for concepts, words that I know about music. So I have, keyboard music, let's say. Okay, what are some words that I know about keyboards? Well, pitch, velocity, timing. Hey, maybe I've got a MIDI protocol. Maybe I have different voices if I have those 16 different instruments that can be controlled on different channels. But maybe I also say, well, that's too limited. I want this to be a forward-looking instrument, so I'm going to add more dimensions. I'm going to add timbre. I'm going to add spatialization. I'm going to add effects. I'm going to add whatever. The proposition would seem to be that having described music this way, that I have essentially taken a set of words, put a set of numbers onto those words, and turned that into a dimension space. And the idea is that making music, therefore, could be described as a navigation of this multidimensional dimension space. I don't necessarily, I don't have a big problem with that idea analytically, but I think the next step then gets to be a bit problematic. I open my toolbox, I get out some sensors, maybe I have an accelerometer or force sensor, some buttons, whatever. I take my favorite computer music language. And what comes out of all of this is a different numerical dimension space, which I purport represents gesture or the person's interaction with the instrument. And therefore, the instrument design proceeds as a kind of assignment from one dimension space to the other. And this is a process that we're very familiar with in digital musical instrument design. It's called mapping. It's extremely useful, actually, as a concept, and it is extremely important. But I think the problem here is that there's so much ideology that takes place in just getting to these representations and building these spaces to begin with, that I think oftentimes gets less scrutiny than it deserves. So looking at mapping from a sort of agri perspective, I guess what I'd claim is that it's a kind of form of representation design, i.e. that our premise is that we have built a conceptual space, and that conceptual space is somehow representative of music, whatever we take that to mean. and that the reason that this works, as we would think as designers, is that somehow we have made a machine that is, kind of aware of the important musical qualities that it is controlling. But the whole idea that the instrument ought to encode some kind of neat symbolic representation of music that's just there for the inspection, that's a choice. That's a choice that we can make. It's not an inevitability. And I think that's important for us to remember. Now, lest it be said that I'm just kind of throwing stones at other practices, I think I want to tell you about this project of mine, which I think actually falls into that trap in a very significant way. TouchKeys is basically, it's capacitive touch sensor technology. It goes on the surface of the keyboard, so it measures where you put your fingers. The idea being that when you slide your fingers around on the keys, you could use that as essentially a kind of extended MIDI control for what the keyboard does. Here's a little video. Incidentally, compare that to the Emerson Quartet playing Beethoven, and you can start to see the sort of paucity of this idea of, that this is a good representation of string playing, but, never mind. Here, I went back actually and looked at what I said about this in NIME 2012 when I presented this, and I had a whole kind of I had a whole story about this, about expanding the expressive range of the keyboard. There's that word, expressive, huh? And then respecting training of skilled performers. Of course, no NIME presentation is complete without a dig at the MIDI protocol. So there we are. It was too discrete, node on, node off. The idea being essentially that we could somehow extend this with lots of extra controls, and that the answer was lots of data flexibly mapped to essentially whatever we want. It's fine. It works. It works well. It does what it does what it says. But I think that what I had in mind as something that somehow was overcoming the limitations of the keyboard and being so kind of open-ended in what you could do actually kind of missed the point. It's it's putting a representation of music ahead of the certain aesthetic experience of making it. And this idea of sort of openness by anything mapping to anything else actually conceals a really strong ideology, which is basically, taking place. Sorry, we got somebody else on the call. Yeah. So, basically, this was maybe not nearly so open-ended as I would have it be. Okay, fine. Back to this entanglement idea. Okay, so what am I proposing then? What's the alternative to this? If no concepts or words have sort of fixed meaning, and the boundaries between humans and technologies and cultural systems aren't fixed in advance, how are we supposed to operate as designers? So the idea is that these boundaries might not be preordained in some sort of universal sense that we can always nail down, but that's not the same thing as saying that boundaries never exist. And this is where I think, again, Barad is a really useful source, talking about design being this process of what they call an agential cut. Essentially, that the ideas of subject and object, cause and effect, essentially come into being because of decisions that we make as designers. And I will attempt a really brief explanation of how Barad gets from Niels Bohr to kind of the ethics of design and responsibilities of design. There is this famous quantum mechanical experiment where basically light or matter, for that matter, can behave either as a particle, where you pass it through these two slits and you see essentially two lines appearing on a screen, or it can appear as a wave where by passing through these two slits, there are interference patterns between them. And what you see on the screen is essentially a pattern of alternating light and dark. What's interesting is that it depends what kind of detector you build. The apparatus that you make to do this measurement literally determines whether the light or matter behaves as a particle or as a wave. And in particular, if you attempt to observe by any means whatsoever which of the slits any given bit of light or matter goes through, it will basically turn it into a particle-like pattern. And if you don't conduct such an observation, it will display a wave-like pattern, more or less. So essentially, the premise here is that at a fundamental level, the things that we are observing and our apparati of observation don't exist independently. They co-constitute one another. They are irreconcilably entangled. And therefore, what Barad is saying is that the fundamental unit of existence isn't sort of objects per se, but what they call the phenomenon, that is, quote, relations without pre-existing relata. So to put it another way, the apparatus co-produces the very phenomena it purports to measure. It's not about making a representation of the world or turning a mirror on the world. There's a kind of process of mutual becoming through what Christopher's already talked about, this process of, quote, intra-action. Now, what does that mean then for instrument design? My suggestion is that the mapping as kind of classically constituted has oftentimes been treated as a form of representation design, wherein we construct stable representations of music or things that we believe to be stably representative of it, and then attempt to sort of use those as control parameters. But that actually maybe the causality runs the other way around. Maybe rather than representing musical ideas, our very conceptual space and the way we treat it is actually kind of bringing those musical ideas into existence. To put a more specific point on it, let's turn to the realm of music informatics. Something that we would maybe take for granted in this day and age is the idea of something like pitch detection, that we could detect the pitch of a musical signal by use of some kind of algorithm, maybe an autocorrelation algorithm or maybe something in using FFTs, and that we could also detect musical onsets. And we can use this, for example, to build MIDI guitars and the like. You can essentially detect note events, give them pitches, and then you can use that to control other sounds. What I would suggest is that this kind of process is actually one of apparatus construction. The pitch detector, the onset detector, it's not like pitch and onset were just ideas that were out there in the world before we started looking at them. The basic idea is that I would actually say pitches don't exist, onsets don't exist. They only exist in relation to the apparatus that we have built to detect it, whether that apparatus is a technical system or our own ears in a particular musical concept. And these are our choices. This is basically our, this is basically our responsibility as designers to decide to bring these concepts into existence. So a suggestion then is maybe we ought to replace the idea of instrument design as a kind of top-down process with something more like discovery or development, distillation, cultivation. Basically, the idea that there are sonic phenomena that exist in the world, and we can discover these, and we can figure out how to shape them into the forms that suit our particular purposes of music making. An example in the electronic world is the famous Cracklebox from Stein, which is a kind of appropriation of this historical 1960s vintage op amp, which the very instability of the thing when operated in this way becomes the sound making of the instrument. So whatever conceptualization of what that op amp was supposed to do is not at all how it's used in the system. Another example we might take as no input mixing. It's hard to describe this as a top-down design process. It's a kind of discovery of what a mixer does when its outputs are patched back into its inputs. Tom's written a really nice paper about no input mixing practices, by the way. And I think there's a reason maybe that feedback systems actually come up a lot in this kind of space. It's because feedback has a useful way of kind of destabilizing concepts and meanings of signals. I'm going to conclude then with just a few examples of things that I would suggest that even if our digital systems construct representations of music, we're not trapped by those representations. As musicians, we can do with them what we want. And so I've got a few kind of possible directions. One is actually, what I'm calling dumb instruments, that maybe the machine doesn't need to know anything about the music that it is essentially being used to create. This is a little example of basically turning television monitors into drums by its Japanese group Electronicos Fantasticos, and I really love this. Let's play a little clip. Anyway, you could find that whole thing on YouTube. But I love the richness of this really simple idea. But of course, the way this works is actually just a pickup worn, or like a kind of a wrist strap worn, plugged into a guitar amplifier, and just working on electromagnetic interference. No knowledge, no conceptualization anywhere in there in the technical system. Another example, of course, is circuit bending. The speak and spell being a famous example. We're talking about basically rewiring. So again, there is a representation in the design of the speak and spell. The designers of that are, following Agri's sort of, critiques of, or they're following the way of thinking about computing systems that Agri is critiquing, but the representation is completely distant from any of the musical uses it's been applied to. Why does it work? Who knows? And where is the neat, inspectable understanding of the aesthetic meaning of this creation? Not there. And another one, then finally, because I rag on MIDI so much, an example of something that works differently is what's come to be called black MIDI, which is essentially just the incredible proliferation of MIDI notes into textures. And I don't know if I can actually. Let's try that. So you can see that the very idea of the note gets a bit destabilized by this kind of treatment. So I proposed the idea that maybe instrument design could be entanglement design, but I think that's actually wrong. I think it's better to describe it as entangled design. Essentially, the idea that we designers are part of this entanglement. We don't stand outside of that and get to say how things will be. That essentially we are inextricably bound up in these entanglements that we are affecting. So back to Agri one final time, he talks about this idea of the critical technical practice requiring one foot in the craft work of design and the other foot planted in the reflexive work of critique. I think this is right. And I'd say that creating an instrument is not about solving a problem, but engaging in an ongoing artistic conversation. So hopefully we can continue that conversation here. If you're more interested in unpacking some of these ideas further, there you can find the Kai paper. Thanks very much.
Okay, thank you very much indeed. So I guess we've got 5 minutes for some immediate questions, though after a short break, we'll come back for maybe an hour or so for questions for both talks. So do we have any questions from anybody? Either with hands up or in the chat, obviously. Thor, yeah, do you want to go right ahead?
Yeah, can you hear me?
Yes.
Okay, great. Well, thanks for a fantastic talk, Andrew, and also Christopher. Really great talks, both of them. I'm thinking about a slide, Andrew, that you had, where you are talking about Barradian apparatuses, and you had the provocation that pitches and onsets don't exist. And I agree with these kind of things. I mean, it's about language, it's about categorizing what is there out in the world. And we have a tradition to pay attention to some things and not to others. So we, in our musical culture, pay attention to these things, and we create language around them. But I think when you are proposing these type of instruments, and with the discovery rather than top-down kind of planning, we are also thinking here about different musical traditions, and we must take into account the musicological kind of evolution that this implies. Because a good old joke in CHIME is how do you play Happy Birthday on this instrument, you know? And we have that melody in our head, and we know how to sing it when somebody has a birthday and so on. So these are pitches and onsets, obviously. And I'm thinking there's something about intention as well, the human intention. The musical act of performing doesn't start when the note happens. It happens in the head of the performer long before. There's some kind of movement, intention. But that intention could be equally one of wanting to play a pitch with an onset in a melody like Happy Birthday. But it could also be the intention of exploring, to go into a space of exploration and discover things. And this is something that we find so much in musical systems today, with performers and composers who create systems to explore rather than instruments to play onsets on. So I'm thinking we just to encourage that we also think about what this means in terms of music and musical tradition and musical changes in musicology. What kind of new music does this imply if you are designing, for example, instruments where it's hard to generate pitches and onsets, you know? So this is a little bit just a commentary on the kind of more musicological, music genre and music kind of instruments. Yeah, the kind of cultural context of it.
Yeah, thanks, Thor. I think those really good points, and I think that raises some important issues. So the thing about onsets don't exist, for example, that this provocation. I guess the idea is that it's not that they never exist in any sense whatsoever. They exist in relation to a particular context and into whether that context is, you know, our perception within a particular kind of musical environment, or a particular technical system that is essentially assigned a kind of on-off number to onset or no onset. And that's partly why I played that Beethoven example, because in a sense, that sforzando, the fourth note of the fugue subject, does it have an onset? Well, obviously it has an onset. I don't think anyone would say that it doesn't. And yet, kind of where precisely do you place that? I think you would find different listeners and different performers would think about that differently. And maybe the act of actually performing it, you have to conceptualize that differently than you do when you're just listening to it. How would you have a digital system decide where to place that? And I mean, we could just say, oh, well, there's a statistical uncertainty. By modeling lots and lots of humans, we're going to come up with some sort of distribution. But I think it kind of misses the point. I think that, you know, somehow the idea is that to even think about onset as being a stable idea that sort of exists prior to our design and prior to our performance and our context, maybe that's less useful than thinking, okay, if my goal is not necessarily a music information retrieval researcher trying to extract symbolic meaning from music, but my interest is as a designer making the tool that somebody is going to play the next piece of music on, maybe I don't need to start with those ideas. Maybe they can be constructed and they can kind of be distilled out of the context that they emerge in, which is kind of what happens with the CRT TV drums. Again, onset's there too, but there's nothing encoded in the system that says it's that way. It's an emergent property. You could say the same about Happy Birthday, actually. Yeah, of course it has onsets, but are the onsets and the pitches necessarily the essence of the melody? I don't know.
But I'm wondering, there might be someone playing the no input feedback mixer who looks at their gestures as some kind of onsets, you know, when they're kind of turning the knob, there's an event. And it might not be called onset, but it's an event in any case. So it is a...
Yeah, sure. And the point here isn't necessarily to say this word is wrong, use that word instead. It's more like things that are useful analytical frameworks to describe what something has happened are not necessarily always useful in the same form as generative elements. And for me, I guess the critique that I'm leveling is that there's oftentimes a kind of inversion going on of taking analyses of things and trying to invert them into syntheses of things, and that essentially that is never going to fully work, and it's not just a case of being better and clearer about what the concepts were in the middle. But what else should we do? I think that's still an open question.
I guess the problem is, of course, that when you program a computer, you kind of have to have some kind of a representation of what is going to happen, and you classify, you do an ontology of the world, of the music, of the domain.
Sure. Yeah. John Bowers is probably worth name checking here as well, actually, because he's got I think it was Bowers, and I think Owen Green as well was involved in this. There was a series of kind of provocations around music technology. I remember one of them being disagreeing pitch trackers, and it was essentially a whole, like, some sort of performance, which was essentially based on the extent to which different pitch trackers disagreed about the pitch of a signal. And it was almost those kind of interference patterns between things that become the basis, rather than the idea that pitch is stable and everybody ought to agree on it. And I think in some ways that's the right way of thinking about what, about the openness of these ideas.
So we've got question in the chat from Joe Trachenberg, who's saying, by questioning this top-down approach of designing an instrument from a conceptual model and planning, maybe you are questioning the design itself of musical instruments. Are you somehow digressing against the design of musical instruments?
Boy, I don't know. I mean, obviously that designing musical instruments is kind of what I do. And I mean, I made a number of them. I guess, I made a critique of my own TouchKeys. I think there are sometimes that things work, and sometimes, maybe things work sometimes for reasons that we don't expect. And that's certainly been the case for other instruments that I've built. And I won't really take up lots of time on this channel talking about that. But I like the idea somehow that instrument design might start by identifying, hey, that's a nifty thing. When you do this, that sound emerges. Or I wonder what would happen if, this particular little phenomena could somehow be put into this context of this musical language that I'm interested in participating in, or something. I don't know, but that maybe will get you a different place. Maybe, I don't know if a better place, but at least a different place than starting with words and concepts and trying to work down into numerical systems. That's what I'm saying, I think.
Okay, so my suggestion is that we take a 5-minute comfort break.